Imagine if you could leap across the universe in the blink of an eye or even travel through time. What if there was a cosmic shortcut that could make this possible? Is it merely a figment of our imagination, or could such a phenomenon exist in our universe? In the realm of theoretical physics, there's a concept that could potentially offer such mind-boggling possibilities. We're talking about wormholes. These are not your garden-variety, soil-dwelling creatures, but hypothetical features of space-time, proposed by certain solutions to Einstein's field equations in general relativity. Also known as an Einstein-Rosen bridge, a wormhole presents itself as a theoretical passage through space-time. This passage could potentially create shortcuts for long journeys across the universe. Picture it as a tunnel with two ends, each at separate points in space-time. It's as if you've got two doorways, with the space in between crumpled into a much smaller size, letting you cross vast distances or even different universes in a heartbeat. But it's not as simple as stepping through a door. The visualization of a wormhole requires us to stretch our understanding of the cosmos. Each end of the wormhole, or the mouths as they're often referred to, are connected by a throat or a narrow passageway. This throat is the key to our cosmic shortcut, the bridge between two disparate points in space-time. Yet, it's important to remember that these are all theoretical constructs. While they are based on mathematical models and solutions to Einstein's general relativity equations, they remain purely speculative. No observational evidence exists yet to confirm the existence of these space-time shortcuts. But what exactly are these wormholes, and how do they supposedly function? Let's delve deeper into this fascinating concept. With this, we embark on a journey to explore the enigmatic and captivating world of wormholes. Hold on tight, as this might be the closest we get to time travel or instantaneous cosmic journeys, at least for now. When we think of wormholes, we are essentially talking about two types: traversable and non-traversable wormholes. Now, what's the difference? Well, imagine you are at the mouth of a tunnel. A traversable wormhole would be like a well-lit tunnel that you can stroll through, emerging on the other side. There are no barriers, nothing stopping you from taking that journey. The passage is clear, and theoretically, you could traverse from one end to the other, even if that means journeying from one universe to another. On the other hand, a non-traversable wormhole is like a tunnel, blocked by a colossal, immovable boulder. No matter how hard you try, you can't get through. This is due to certain physical constraints, such as extreme gravitational forces or high-energy particles, that make passage impossible. Now, why are these distinctions important? Because they can drastically affect our understanding of the universe and its possibilities. If traversable wormholes exist, they could potentially serve as shortcuts for interstellar travel or even inter-universe journeys. Imagine being able to hop from one galaxy to another in a blink of an eye, or crossing into parallel universes. It's a tantalizing prospect, isn't it? However, non-traversable wormholes, while seemingly less exciting, are still extremely significant. They challenge our understanding of the nature of space-time and pose intriguing questions about the fundamental laws of physics. Even if we can't traverse them, their mere theoretical existence forces us to rethink what we know about the universe. But remember, traversable wormholes aren't exactly a walk in the park. Even if they do exist, traveling through them would require overcoming numerous challenges, including the potential for catastrophic collapse and the need for a yet undiscovered form of negative energy to keep them stable. Thus, not all wormholes are created equal. Some might allow passage while others remain locked. But whether they are traversable or not, wormholes continue to captivate us, offering tantalizing glimpses into the mysteries and potentials of our vast universe. Creating wormholes is no easy task, at least theoretically. It involves exotic matter with negative energy density, something that is still largely speculative. Imagine trying to keep a tunnel open underwater. You'd need something to hold back the immense pressure of the water all around, to maintain a clear passageway. That's a bit like what we're dealing with when we talk about wormholes. But instead of water, we're trying to hold back the fabric of space-time itself. Enter exotic matter. This theoretical substance is said to have negative energy density, which, in the realm of physics, is a bit like saying it has anti-gravity. It's this anti-gravitational property that could, in theory, keep the throat of a wormhole open, preventing it from collapsing under the immense gravitational forces at play. Now, we say could, because exotic matter is still largely hypothetical. We haven't found any yet, and we're not entirely sure it even exists. But if it does, it might just be the key to creating and maintaining a wormhole. But there's another hurdle. According to Einstein's theory of general relativity, wormholes are inherently unstable. Without the presence of exotic matter, they would likely pinch off or collapse almost immediately after forming. This is because the very fabric of space-time, the stuff wormholes are made of, is in a state of constant movement. It's a bit like trying to build a sandcastle on a windy beach. Without something to hold it together, the sandcastle, or in our case, the wormhole, will simply be blown away. So creating and maintaining a wormhole is a bit of a delicate balance. We need the right conditions, the right materials, and a whole lot of luck. And even then, we're not entirely sure it's possible. But that's the beauty of theoretical physics. It's all about exploring the possibilities, pushing the boundaries of what we know, and daring to imagine what might be. The creation and stability of wormholes are delicate issues, and we're still in the early stages of understanding these complex phenomena. One of the most intriguing and tantalizing aspects of wormholes is their potential for time travel and interstellar travel. Imagine for a moment stepping into a traversable wormhole and emerging light years away, or even in a different time. The very concept of time travel, often relegated to the realm of science fiction and fantasy, becomes a theoretical possibility with the concept of wormholes. However, this potential is not without its paradoxes. Consider the famous grandfather paradox, where one could travel back in time and prevent their grandfather from meeting their grandmother, thus preventing one's own birth. It's a mind-bending conundrum that highlights the complexities and potential pitfalls of time travel. Now let's journey beyond our own timeline and consider the potential for interstellar travel. Wormholes, like cosmic shortcuts, could theoretically allow us to traverse vast distances across the universe in an instant, surpassing the speed of light without violating the laws of relativity. Sounds like something out of a science fiction novel, doesn't it? Yet, this is the tantalizing potential that wormholes present. Imagine, if you will, a universe where interstellar travel is as common as catching a flight from New York to London. A universe where the farthest reaches of space are not separated by insurmountable distances, but are merely a wormhole away. The potential for exploration, discovery, and understanding is beyond comprehension. However, it's crucial to remember that these prospects, as thrilling as they may be, are purely speculative. Despite the captivating allure of wormholes and the potential they hold, their existence and practicality remain unproven. They are, for now, theoretical constructs based on mathematical models of spacetime. Such is the nature of our universe, a complex, mysterious entity that continues to challenge and inspire us. Wormholes, as theoretical gateways to other times and places, represent one of the many enigmatic aspects of our universe that continue to fuel our curiosity and drive our quest for understanding. While the practicality and existence of wormholes remain purely speculative, they certainly offer some tantalizing prospects for travel and exploration of the universe. Despite the captivating concept, there is currently no observational evidence for the existence of wormholes. They remain purely theoretical constructs. This is a sobering truth we must face when we delve into the enigmatic world of wormholes. As it stands today, these supposed shortcuts through space-time are born of the rigorous equations of Einstein's general relativity, yet they elude our observational capabilities. These beings of mathematics, invisible to our most advanced telescopes, continue to be the subject of fervent research in the realms of theoretical physics, cosmology, and astrophysics. They are like ghosts in the cosmic machine, their presence felt only through the tantalizing solutions they offer to the equations that govern our universe. Researchers around the globe are tirelessly investigating the theoretical properties of wormholes. They're exploring the exotic matter that could potentially keep these cosmic tunnels stable, the shapes they could take, and the paradoxes they could create or resolve. Despite their elusive nature, wormholes have managed to carve a niche for themselves in the scientific community. They offer an exciting playground for thought experiments, pushing the boundaries of our understanding of the universe. The potential implications of wormholes are not lost on researchers. The prospect of faster-than-light travel, of visiting distant galaxies, or even of time travel is enough to keep the scientific curiosity alive. Yet the reality of these possibilities remains purely speculative. The journey to unravel the secrets of wormholes is not a sprint, but a marathon. A marathon that requires patience, perseverance, and above all, the willingness to embrace the unknown. The path is fraught with uncertainties, and the destination remains shrouded in mystery. Wormholes, with their potential for exotic travel and exploration, continue to captivate and intrigue us. However, we have a long way to go before we can confirm their existence or use them for travel. Until then, they remain one of the most fascinating mysteries of our universe.